The topic is 3D printed antennas, its design methodology and challenges. And today it is my great pleasure that we have with us our honorable speaker who is expert in this domain, especially on 3D antenna, and he is from Alexandria, Egypt, Dr. Ashraf E. Ahmed. So I would like to share a few details about him to you, because it really makes a good bonding between the participants and the speaker too, if you know about the speakers. So Dr. Ashraf received his BSc, MSc and PhD degrees from Alexandria University, Egypt. And he is an expert in this RF microwave related domain. Presently, he is professor in Higher Institute of Engineering and Technology, Alexandria, Egypt. His research interest includes designing of smart antennas, the different configurations of microstrip patch antennas, microwave filters, and MIMO antennas in wireless communications. And apart from all this, he is an expert in designing, material selection, and implementation or realization related to 3D printed antenna. And one more thing I would like to share with you that presently I am having collaboration with Dr. Ahmed. Recently we have finished one of our work on multi-band 3D printed antenna. So really it's pleasure, and in future, after the ending of this session, if any participants wants to collaborate with us in this domain, we always welcome him, her or them to be associated with us. It will be really our pleasure, because in this domain drastically it is changing and we have lots more things to learn to adapt ourselves in this domain actually. So really it's my pleasure, and thank you, Dr. Ashraf, that you accepted the invitation I sent to you on behalf of IMPS College of Engineering Technology. I welcome you to this session as an expert, sir. Sir, please, over to you. You carry on. Hope it will be a good session.
Okay. Okay. Good evening, everybody. Welcome with all. Our presentation show the 3D printed antenna design methodology and challenges. 3D printed antenna in our presentation in two works, each in batch and another work each in substrate. First work, analysis and design of 3D printed fractal triangle antenna for wireless communication applications. Outlines and introductions, 3D printed triangle fractal antenna design, model 1, model 2, model 3, the batch antenna shape equilateral triangular antenna. Design methodology of proposed antenna, triangular antenna design, accurate fractal antenna design, then current distribution analysis and result and discussion conclusion. First work use Serbinsky fractal antenna. Introduction with the progress of wireless system and important increasing of other wireless application. Wide band, low profile, low weight, and low cost antenna are highly required for industrial application. Multi-band and wide-band antenna are desirable in wireless communication system. The 3D printed antenna based on Serbinsky fractal concept, contour, slot batch is studied. All the antenna models are designed in operate for Bluetooth, WLAN, Wi-Fi, and S-band with C-band system with S parameter less than -10 dB with the band around 2.45 gigahertz. In this work, analysis and design of 3D printed fractal triangular antenna will be introduced and investigated. 3D printed triangular fractal antenna designs. The proposed antenna structure have been designed using PLA substrate. In this case, we use PLA substrate with epsilon r equal 3.1, loss tangent equal 0.001, and thickness 3 millimeters, with size as shown. First model of triangular antenna batch used. The antenna was designed to use equilateral triangle batch made of red copper, feed by lambda over 4 quarter lambda transmission line, and adjustment use 2 stub, upper stub and lower stub. Upper stub length lambda over 8, and lower stub lambda over 8 to adjustment operation and tuning, and do parametric analysis is used for upper and lower stub to get the optimal matching at 2.5 gigahertz and reach it S11 up to minus 27.7 as shown in this figure. 3D printed. Model 1 antenna layout, model 2 simulation, return loss versus frequencies. This is the first model operate around 2.5. Model 2 used triangular antenna. The fractal used in inverse equilateral triangle shape. Used the fractal antenna, iteration fractal antenna, and gave suitable operation antenna band at 2.3 giga, and the return loss reached to minus 1.5 dB. In this case, we cut the triangular by laser machine in the red copper and inverse directions of the triangular, equilateral triangular, to effect on the electrical lens, and the same triangular in fractal to effect self-similarity. And this shape get S11 as shown. The 3D printed model 2 antenna layout, B simulated antenna, reached to minus 215 return loss or reflection coefficients. Model 3 of triangular antenna, the fractal has been implemented by using inverse triangle shape to obtain second iterations and to achieve the resonance frequency at 2.3 gigahertz accurate, and S11 reached to 4.08. The second iterations we cut by fractal antenna design, select equilateral triangular, and adjustment by using upper stop and lower stop to get the optimal position on the transmission line lambda over 4 or quarter lambda, as shown in figure, and reached S11 versus frequency as shown. The 3D printed model 3 antenna layout, B simulated layout. Design methodology of proposed antenna. This is a good antenna, fractal antenna. We use the same shape cut by using laser machine, but the substrate using 3D printer machine. I used 2 machines, laser machine and 3D printed machine, to design the final model, and the connectors SMA solid welding in here, and tested with VNA vector network analyzer. Design methodology of proposed antenna. Triangular antenna design. The patch and the ground are embedded in the substrate. Since the substrate is 3D printed and covered by double side cover, the equilateral triangle side was calculated using the following equations to calculate the side of the equilateral triangular side A effective. We get from these equations using epsilon r 3.1 and the loss tangent 0.001. height 3 millimeters, and embedded a patch and the ground for the substrate to fix the antenna. Accurate fractal antenna design, the final efficient fractal antenna model 3 give excellent operation antenna band around 2.3 gigahertz, and S11 reached to minus 4.08 decibel as shown in figure. Comparison of the model S11 result, model 1, model 2, model 3. Model 3 is the efficient because the return loss reached to minus 30 dB and accurately and 2.4 gigahertz. Then current distribution, surface current density and of the 3D printing fractal antenna, and this is first model, second model, third model. Current distribution, it can be observed from that the current distribution is uniformly distributed at the resonance frequency of each model. A high current can noted at the corner of the each fractal structure, confirming the improvement of the impedance characteristic when the number of iterations are increased. Here in the corner, the current distribution very good, and can be applied third iteration, fourth iteration, 1 triangle, 3 triangle, and they can cut off third iteration, fourth iterations. Result and discussion. Fractal method with self-similarity for the main geometry shape antenna must be the same geometry. Triangular can be bifractal cut by triangle with laser machine, give multi-band frequency, and inverse direction shape increase the electrical length of antenna. Therefore, enhancement the fringing field distribution and performance of antenna, and we can reduce the surface wave to enhancement the operation of the antenna. First model, we manufacture it. Second model, third model, and test the third model by VNA vector network analyzer. This is the best model operation at 2.4 and adjust the tuning by the two stub, upper stub and the lower stub to get the optimal position of operation. Simulate in this figure, simulated and measurement return loss S11, model 1, model 2, model 3. This is the model 1, model 2, model 3, dash blue measurement curve, and red simulation. The model 2, model 3, model 3 give minus 34 dB because the iteration using fractal antenna design. The desired performance for any WLAN antenna is an omnidirectional and radiation pattern as shown in figure 8. The radiation pattern in both E plane and H plane and the resonance frequency for each model. Figure 8 simulated E plane dash and H plane solid, E plane dash and H plane solid. Model 2, model 1 at 2.5 gigahertz, model 2 at 2.35 gigahertz, model 3 optimal models at 2.34 gigahertz. Second work different from the first work in main manner. In this search, we etched in the substrate only, not batch as the same. We etched the iterations in the substrate only, batch and ground as the same, not cutting, using 3D printed antenna. Second work, a novel multi-band antenna with 3D printed multi-circular substrate for wireless application. Outlines and introduction. Antenna design, two models, model 1, model 2 of 3D printed circular antenna, 3D printed circular antenna model 2, design methodology of the proposed antenna, circular antenna design, efficient antenna design, current distribution analysis, result and discussion conclusion. In second work, we cut only substrate and using 3D printer machine, but batch and ground cut it by laser machine. In this, we fix it by screw nails from BLA substrate height 1 millimeter. An introduction: due to the recent evaluation of 3D printing technology, researchers can fabricate affordable and versatile antenna to adapt with the fast advance in RF system. Multiband and wideband antenna are desirable in wireless communication system. In this search, a circular shape antenna is proposed using 3D printing method, design, simulated, and measured. The circular antenna is matched using stubs, but put on the perimeters of the circular disc. In this search, the 3D printing multi-circular technique is etched in BLA substrate, only as a novel manner to get the multiband. The two models of antenna are designed to operate for Bluetooth, WLAN, WiMAX, and S and C band. S band from 2 to 4 gigahertz, C band from 4 to 8 gigahertz. 3D printed triangular antenna, triangular fract antenna design. The proposed antenna structure have been designed using BLA. In this work, we used BLA substrate and printed it by 3D printer machine using epsilon r 3.1, loss tangent 0.001, each thickness of substrate 1 millimeter, antenna size as this. Small and accurate. A model 1 of 3D printing circular antenna. The antenna was designed using circular patch made of red copper with effective radius equal to 20.8 millimeter and thickness 1 millimeter, ground plane from the same material, red copper. The antenna is fed by lambda over 4 quarter lambda feed transmission line, and using two stubs, lambda over 8 and lambda over 16, to get the tuning and matching, and analysis studies to get matching, and the stub here put on the perimeters. Two stubs or signal to each other on circular perimeter to achieve the best matching. We use 3 screw nails from BLA to fix it all the system, all the antenna, and connect the SMA connector here on transmission line. The result return loss as same. Antenna A, antenna layout, B, simulation result. 3D printed model 1. This is model 1. This is batch and substrate not cutting in. Model 2 of the 3D printing circular antenna. The proposed model used a Ballonian gasket by 3 circular shape with radius 7.66 millimeter, and we etched it in the 3D printing substrate only. Here we cut on the substrate only by 3D printer machine. Resonance frequency at 2.4, 2.7, 3.4, multiband 5.3, and get return loss as shown, minus 27 and minus 15, minus 25, minus 25.4 respectively, as shown in the figure. B, simulation frequency, A, antenna layout, and the multi-circular etched BLA in millimeter. Here we etched in BLA with thickness 1 millimeter. and fixed it by screw nails, 3 screw nails from BLA screw nails material. Design methodology and the proposed antenna, circular antenna design. In the first model 1, the antenna is formed by using copper of thickness 1 mm as a radiating patch, as well as a ground plane as the same material from red copper. The substrate is 3D printed with multi-circular cut of a novel idea to the achieved multi-band performance. The radius of the circular patch antenna was calculated using the following equations. The following equation to get the
we are not able
effective radius.
PPT.
Okay, the voice is clear. Voice is clear.
The voice is clean, or PPT.
That
Okay,
voice is clear, but the PPT is not visible.
Dr. Ashraf
Okay.
Beltaeb presentation. Participant, please do not interrupt in between the session.
Okay.
Please pin on Dr. Ashraf Beltaeb presentation. Hope you have understood.
Okay. Okay, I will continue. Efficient antenna design. The ultimate proposed efficient antenna model 2 gives excellent performance for the antenna multi-band frequency in terms of return loss. When the multi-circular geometry is etched in the substrate only, the value of the reflection coefficient are deeper than that the model 1, and the resonance frequency matched at the desired frequency for WLAN and WiMAX and S-band and C-band application. Design procedures: BLA substrate for model 1 and model 2, units in millimeters, B11 return loss or reflection coefficient in dB, result S11 as shown. Red for model 1, blue is for model 2. Current distribution analysis. Surface current density of the 3D multi-band antenna for model 1, B for model 2. It can be observed from the current distribution is uniformly distributed at the resonance frequency of each model. A high current density cannot sit at the entrance of stub in model 2. Entrance of stub in model 2 by using the etching multi-circular structure in the BLA substrate, confirming the development in the impedance matching. In entrance of two stub, normal for first stub, and parametric study to get the optimal position here. Result and discussion. Figure 5 shows the photograph of the fabricated antenna model 2 to confirm the authenticity of the proposed 3D printed multi-band antenna to be used in Wi-Fi and WLAN S and C band applications with low weight and low cost, small size, and enhancement performance. The fabricated prototype has been measured using ZVB20 VNA vector network analyzer. As shown in figure, this is the model for 2 second model circular antenna, and the etching in the BLA only, and fixed by screw nails from BLA to fix it, and SMA connectors here. Photograph of the fabricated antenna model 2. Figure 6, simulated and measurement return loss S11 for model 2. Measurement by blue dashed and simulations by red. S11 versus frequency. We reached good result for second model circular. The measured result of S11 shows in figure 6 having 3 resonance frequency, 2.4 2 and 3.25 gigahertz and 5.3 gigahertz, reached to minus 33 and minus 4, 1.8 and 21.1 decibel respectively. It's good result to work in Bluetooth and WiMAX and WLAN and S and C application. The desired performance for any WLAN WiMAX antenna is an omnidirectional radiation pattern, and this requirement has been achieved as shown in figure 7, which shows the radiation pattern in both plane. E plane, we concentrate on E plane and H plane to get the optimal radiation pattern, which matching for operating WLAN or WiMAX or Bluetooth at 2 of the resonance frequency of model 2. Figure 7 simulated E plane dash E plane dash H plane solid for model 2 only. For model 2 at 2.4 gigahertz and 3.22 gigahertz. This is omnidirectional antenna E plane and H plane. Conclusions. First work, the concept of the fractals has been applied to design multi-band antenna models based on the Sierpinski Jasket fractal shape for WLAN or Wi-Fi WiMAX application. The 3D printing technique is accurate and reliable manner for fabricating different radiating shape structures. The measured and simulation S parameter have been introduced to show that the 3D printing fractal equilateral triangular antenna iteration have an excellent performance to meet the need for wireless communication application. When the iteration increase, the performance enhancement. When the iteration increase, the performance enhancement. There is a slight difference between simulation and measurement result that may be occur from the fabrication inaccuracy or welding or accuracy or tolerance due to welding SMA connectors. In second work presented an effective method to achieve a multi-band antenna by using the innovative manner as a multicircular etched in BLA substrate only. Etched here in BLA substrate, not in batch or ground, only in BLA, based on the Apollonian Jasket shape using 3D printing method. 3D printing method is very good manner to because we can control the thickness of the substrate and the shape and use the printers to confirm what we need the shape. The measured result for a proposed model 2 antenna operate at tri-multiband. It can be used S band from 2 to 4 gigahertz, C band from 4 to 8 gigahertz application. There is a slight difference between the simulation and measurement results that may be occur from the fabrication inaccuracy and welding of the SMA connectors. In my work, future work is very good. Future work is using 3D printing techniques in the design and analysis for each of linear antenna, linear array antenna, planar array antenna, MIMO electronic scanning 2x2 or beam steering, and this is a very important point. Advanced RF energy harvesting antenna system, we can apply all this, and the massive MIMO antenna system based on the shape of the antenna which we designed for wireless communication applications. Thank you. Any question? Hello? Any question in 2 words?
You may ask, participants, you may ask questions. You are requested to write your questions in the chat box.
Any question in 2 words? Any question in 2 words?
Hello.
Welcome. Welcome. Any question in first word or second word?
Please write your question in the chat box. Please write your question in the chat box.
Hello.
Any question in the hello?
Please write your question in the chat box, please. Please write your question in the chat box, please.
Any question in the first word or second word?
Hello.
Welcome. Hello. Welcome. The advantage of 3D printing, very good manner to control the thickness of the substrate.
Hello.
Welcome. Hello. Welcome.
Participants, if you are having questions, please write it on the chat box, because if you try to contact him individually, session will never can be ended. Please write it in the chat box. I will read out some selected questions for him. And after that, still if you have many questions, I will provide my mail ID. You can drop your questions. We will answer you very shortly. Please cooperate.
Okay, any question can you send to me in email and I reply. If any question,
yes,
2 works.
Yes, I am reading out few questions, Dr. Ashraf. Just you answer few questions. Someone is asking exactly what is the difference between planar and 3D antenna.
Again, different between triangle and.
Yes, what is the difference between planar antenna and 3D antenna?
The difference of the two antenna. The first antenna is I used shape triangular antenna and used Sierpinski fractal, but the second antenna I used circular antenna referred to a Apollonian gasket, and not etched in the batch, etched in the substrate only due to the Apollonian gasket, and enhancement the performance when etched in the substrate only as a new manner, and get many multi-band operations.
Okay, and one common question that is coming from so many participants, that they are asking what is the advantage or what is the applications of 3D antenna, or what is the limitations of 3D antenna? What is
the limited?
What are the advantages or applications of 3D antenna, and what are the limitations of 3D antenna?
Okay, the applications of the two antennas, triangular and circular, can be applied on the Bluetooth and WLAN and WiMAX, and any application in S and C band. Because the return loss gives the S11 result as shown. We can applications on many communication applications, and we can get in radar system, which work in S and C region.
Actually, they are asking that we are already having microstrip patch antenna. We are already having multi-band microstrip patch antenna through different kinds of feeding, coaxial or CPW or microstrip like that. But participants are asking what is the specialty of 3D antenna.
The advantage of 3D antenna different from the microstrip antenna, because the thickness of the patch here 1 millimeter and thickness of ground 1 millimeter, and you can design any thickness you want. But microstrip antenna is small height, Here we can change the thickness and height of the substrate to overcome the surface wave and enhancement the fringing field. The challenge is here that we can how we tune the patch antenna to work, and we can change the thickness of the cover and the thickness of the ground, or thickness mainly the shape of substrate by the difference of the microstrip antenna with small size, and we can overcome the surface wave and the fringing field.
Okay. And one interesting question that as a researcher, we are.
But the main principle must be take care. How can fix it? I fixed it by screw nails, BLA screw nails, because overcome the air gap. And when measured, because overcome the air gap. It's a modern 3D antenna. We can fabricate MIMO and massive MIMO, not microstrip antenna, because the 3D printed antenna overcomes the advantage like surface wave, enhancement, fringing field, and get good pattern, and so on. Thank you. Another question?
Okay, one more question. Nowadays, it is become very trendy that as a researcher, we are focusing on 5G technology in the millimeter wave band, millimeter wavelength band, and or terahertz frequency. So one question is coming from Kalyan Paul. Can 3D printed antenna be designed for mm wave or terahertz frequency wireless communication?
Yes, can work in 5G antenna, because we get 5.3 gigahertz work at this region, and 3.2 and 5.3 works in the region of the 5 generations. The first antenna reached the frequency band. The first antenna works in 2.4. Circular antenna can work in 3.2 and 5.3 in 5G. Maybe work in LTE. Maybe. Any another question?
And one next question. Yes, one last question I will take. Many participants are again want that if you just briefly explain actually the fabrication process of 3D antenna, how you cut the copper, or how you will proceed with that. Actually, how 3D antenna can be fabricated.
How 3D printed antenna get it?
Fabricated. How it can be realized. How it can be fabricated.
Okay, the realization steps. First, designs equations of the antenna, batch antenna, any shape, circular antenna, rectangular antenna, batch and elliptical antenna. We calculate the radius and choose the cover, read cover, then cut it with the computer files, STL files with laser machine. Second step, design the substrate accurately by the equations, and go to the 3D printers by another file to printer and using 3D printer. Then we get batch and ground after cutting it by laser machine with accurate dimension. Second, get the 3D printer after cut it by 3D printers, and fix it all by screw nails. Fix it all as the circular antenna. Screw nails with diameter with radius 1.5, fixed all, and welding SMA in the side of the transmission line feeding, and test it on VNA. Test it on VNA, and you can test it the radiation pattern and gain in the economic chambers. But here I test it VNA only, vector network analyzer, to ensure it operate or not. The main step must be good fixing the three parts, bed and substrate and the ground, to minimize air gap for the design. Then soldering then welding SMA connectors and test it. This is the realization process steps. Okay, and the final test the radiation pattern and S11 result and visual voltage standing wave ratio. Test all this to ensure the all parameter is good to work, and the tune in the design tune the patch antenna by 2 steps to ensure it work at 2.4 and or any frequency you want. And another work for me, I designed in 10 gigahertz, but trapezoidal antenna. Another work, trapezoidal antenna work in 10 gigahertz. Another work. Any question?
Okay, Dr. Ashraf, I'm not taking any more questions. We are having 1 hour session, so I think you have tried to answer a few questions in very well manner. And as we know, it's a limited time period webinar, so we cannot accommodate all the questions and answers. But definitely, I have shared my mail ID to the candidates in the chat box. As we are already having collaborations, we are also having many Indian professors on my many Indian friends, many foreign friends. Jointly, we are making up team, and I can found a few names. They are also present here. That I can found one name, K. Basubabu from Andhra Pradesh. He is there. We work jointly in many previous joint works. So in future also we can carry out that. And if you have any more questions, please mail the questions. I have shared my mail ID. Definitely we will try to be in touch.
Okay.
And so lastly, I will like to conclude the session. So Dr. Ashraf, on behalf of IMPS College of Engineering and Technology, really I would like to thank you for accepting our invitation and delivering such an informative, interactive and interesting session to all of us.
Thank you very much.
And really the topic is one of the most acclaimed one in this RF. And really the topic is one of the acclaimed one in this RF and microwave domain. And we wholeheartedly thank you for spending your precious time with us. It was really nice having you, and hope in future also for some lengthy sessions we can be associated with you. We will again invite you for the next few webinars. I have more plans related to antenna and especially components required for 5G systems. So hope participants have enjoyed the session within short time. I really found it to be a nice one. So thank you very much, and good night.
Thank you for all, and any questions send to me in email. Thank you for all. Thank you. Bye. Thank you.
Yes, sure. I will do that.
Thank you.
Sure.
Thank you, Dr. Das. Thank you for all doctors. And greeting.
And now I would like to request Professor Ghosh, Professor.
And greeting for all.
Yeah. Now I would like to request Professor.
And greeting for all participants.
Yes, please tell me.
Thank you, Professor Ashraf, for the wonderful presentation.
Yes. And now.
Thank you very much.
Yes,
thank you. Greeting for all.
We hope to listen from you soon, sir. Now we will share the feedback form in the chat box. Please do not leave this session without filling up that form for the successful generation of the e-certificate, and you will receive your e-certificate within 14 working days in your email ID, which you will provide in the feedback form. Thank you all again. Thank you, Professor Ashraf.
Thank you very much. Thank you. Welcome. Welcome. Thank you. Thank you. Goodbye. Goodbye.
Goodbye. Goodbye, sir. Goodbye. Feedback link
Goodbye.
has been provided in the chat box. Please please fill up the same.
Okay. Salam alaikum. Goodbye. Thank you. Thank you very
Goodbye,
much.
sir. Goodbye. Thank you. So participants, you are requested
Participants,
to fill
please
up
here
given,
just matter of 5 or 10 minutes.
yes, please fill up the feedback form. Link already has been provided in the chat box.